The label substitution. Here you can see for a node, four incoming packets are coming with the labels A1, A2, A3, A4, and the these four A1, A2, A3, A4 are being removed by this node, and the new labels B1, B2, B3, B4 are being attached, and it is being sent to the next hop. This is called as label substitution or swapping. And before we learn the MPLS process, we have to learn about some of the terminologies. LSR, which is label switch router, LER, label edge router, LSP, label switch path, LFIB, label forwarding information base, and FEC, forward equivalent class. First is the LSR, which is label switch router, which are all routers that support MPLS are called as the label switch router. And then LER, the LSRs, the MPLS supporting routers which are present at the edge of the network called as the label edge router. Yes, and then the label edge router can be a ingress node or an egress node. If it is an ingress LER, then it is only responsible for adding the label to a incoming IP packet. And if it is an egress LER, then it is responsible for removing the IP packet and forwarding it to the destination node. And then LSP, which is the label switch path. This is the path defined by the LER between the through the label switch routers. So yes, between the source and destinations, there will be an edge routers. That is between two LERs. It has to find the label switch routers. So that is the label switch path. And then LFIB, the label forwarding information base. It is nothing but a database or a table that contains the mapping between the labels and the outgoing interfaces. And the last one is FEC, which is forward equivalent class. So all the IP packets which have the similar characteristics should be forwarded through the same path, and every node will be giving the same priority for such characteristics packets. So that is the forward equivalent class. Then coming to the MPLS process, what happens when a packet is being generated? Suppose a packet is being generated by a host and then it will be forwarded. So the label edge router is responsible to attach a label to it. So the first step is an incoming packet, a label will be attached and then it is sent through the label switch path. So yes, with the help of label switch path, it takes the path, it goes to the next node, and at the next node, the that particular router will remove that existing label and it will attach the new label to it and forward it to the next hop. So that is the main work. So here the label switch path, what is the use or advantage or benefit of this label switch path? Yes, the LSPs are established by the network operators, and you are getting lot of advantages. Three of the advantages include guarantee a certain level of performance. Yes, we have some guaranteed performance, and then to route around network congestion, since because the node or the router or the label switch router takes a decision based on the current scenario among the available links, so it can avoid the path which is already congested. Otherwise, it can avoid the network congestion also. And the third one is to create IP tunnels for network based VPNs. There is no need to go for some additional technology or a complex technology. Rather, the existing technique itself creates a tunnel for network based VPNs. Yes, we have this LSPs refers to some kind of predefined paths. It is somewhat similar to the circuit switched path in ATM or frame relay network. But this unique feature of MPLS is it is not dependent on any particular data link layer technology. It can support any of the transmission medium. So that is the advantage. It has been explained over here. An LSP can be established across